Hello, welcome to 2.7 Applications of Proportions. In this lesson, we are going to be able to use proportions and similar figures to solve problems. Please go ahead and copy the target now. We'll talk about two vocab terms, right? Right here, the first one being congruent. The word congruent means the exact same size and shape. So copy that down, and then we can draw a triangle and then draw another triangle, which looks to be the exact same size and shape. We would say that these two triangles are congruent. The next vocab term that we need to be familiar with is the word similar. When we talk about similar figures in math, we talk about figures that are the same shape, but not the same size. So they're similar. So if I'm over here on the left, I can draw a big triangle, and then I'll draw a smaller triangle. And those two figures are considered similar because they're the same shape but not the same size. All right, hopefully you have those filled out now. So something that's important is that two figures are similar if and only if the ratios of the corresponding sides are proportional and all pairs of corresponding angles are congruent. Ooh, so what does that mean? So let's go ahead and let's draw two more triangles, okay? So I have this triangle and I have this triangle. Notice my left one is bigger than my right one. So these figures would be considered similar if the ratios of the corresponding sides are proportional. Okay, remember proportional means that, remember, like 1/2 is proportional to 2/4, because when I cross multiply, I get 4 = 4. All right, so what we need to do is that with sides in this triangle. But I want you to really focus on corresponding sides. So corresponding sides mean they're in the same relative position. So circle this side, or color it in another color, or circle, either way. And then the side that corresponds it would be this side in the smaller triangle. Those two sides are corresponding. I'm going to use green. Can you figure out what the corresponding side is to the green side in my bigger triangle? Hopefully you circled this side in the smaller triangle. Those two sides correspond. So that's important when we go through this lesson, because we need to make sure that we have corresponding sides and we can identify them, because that will help us make the ratios. All right, so let's look here at number 1. This shape is called a trapezoid. Okay, now notice that my second shape, my smaller shape, is oriented a little differently. But that's okay. As long as we can identify corresponding sides, we should be good. So let's look here. It says find the missing length. So I'm going to circle X because that's clearly the missing length I need in my bigger trapezoid. What side corresponds to this side AD in my smaller triangle? Okay. Well, if I can rotate this smaller trapezoid, if I rotate it or look at it a little differently, 2 inches, the side MN corresponds. Okay, well, great. But now I'm going to look, well, what other measure corresponds, or what other side lengths correspond? So I'm going to use, and again, if you're paper pencil, I'm going to use a triangle here. For side AB, I'm going to say, well, side NO corresponds. So what I'll do is I will set up my proportion by saying that AB, okay, which is 7, Okay, 7 to 5. Notice I'm going to take 7 to 5, and I'm going to have a little label of big to small. Okay, I can just use B and the letter S. All right, so that side, AB, corresponds to this side, and then I'm going to carry my labels over because I need to go big to small on my second part of my ratio, or my proportion. So X to 2. All right, now we remember from sections 2-6, we are going to use cross multiplication in order to solve for that value of X. So 7 times 2 is 14. 5 times X is 5X. In order to solve for X, I have a one-step equation. Multiplications in between 5 and X. In order to undo that, I divide. So X is equal to, you should get a decimal, 2.8 inches. So I know that this missing side length is really 2.8 inches. And again, using corresponding sides. Let's go ahead to number 2. Notice I have a triangle inside of a triangle. So I have a red triangle here. Okay, and then I have a bigger triangle. So I'm going to take my red triangle and I'm actually going to draw it outside of the given figure. And I'm going to carry my labels as well. 3 centimeters, and then this is X centimeters. I'm now going to take my blue triangle, and I'm going to do the same thing. I'd like you to do the same thing too. Hit pause if you need to. Now when I look at the entire length AD, I need to look over here. The entire length of AD is 4 and X, which is 4 plus X. So now I am looking for that missing length, like I'm looking for that value of X. All right, so I can use the idea of corresponding sides. All right, so BC, the bottom of the triangle or the base of the triangle, corresponds with what on the bigger triangle? 6. All right, so I can set up 3 over 6, and this time I'm going small to big. My small triangle to my big triangle. I'm going to carry those labels over because that will help determine where I put my missing value or my other values. This side length is X, and this side length is 4 plus X. So X, 4 plus X. Remember, when you have an expression, you need to put that expression in parentheses because we'll have to do the distributive property. All right, so let's cross multiply just like we would before. 6 times X is 6X equals 3 times 4 plus X. I'm going to write it like this. I must use the distributive property with multiplication. 3 times 4 plus 3 times X. So I'm going to carry down my 6X equals 3 times 4 is 12 plus 3 times X is 3X. Let's go ahead and move this 3X, right? Make 0 pairs here. If I subtract 3X from the right, I must subtract 3X from the left. And I'm left with 3X equals 12. One step left, I will divide both sides by 3 and get that X is equal to 4. So let's go back into my picture. Can I determine the side length of AB? I can. It's X, and we know that X is 4. So 4 centimeters. Can I determine my length of AD? I can. It's 4 plus X, which is really 4 plus 4, or 8 centimeters. That's using similar figures with geometric figures, right? Like geometry figures, trapezoids, triangles. We'll see more triangles here when we move to the next section. Okay? All right, but we're applying this idea of proportions to, and now, real life objects. So indirect measurements, okay? So indirect, meaning not direct measurement. If two objects form right angles with the ground, you can apply what we know about similar triangles and proportions to solve for a length that is not easily measured. So think about like how tall a tree is, how tall the flagpole is, things that we just can't easily grab a ladder and measure. So we can use this idea of similar triangles and proportions to help us determine different measurements. Let's take a look at number 3. A flagpole casts a shadow, okay, that is 75 feet long. Excuse me. At the same time, a 6-foot man casts a shadow that is 9 feet long. Write and solve a proportion to find the height of the flagpole. So we need to make sure we can draw a picture. All right, so the information we have about the flagpole is that it has a shadow that's 75 feet long. So I'm going to draw a flagpole, okay? And I do not know the height, right? The height is the unknown. We don't know what the height is. So let's call that X. However, I do know that the flagpole has a shadow, right, of 75 feet. Now, I have a 6-foot man that casts a shadow that's 9 feet long, okay? So now let's draw a man. Stick figures are fully acceptable. And I know that he is 6 feet tall. And his shadow, okay, which I'm just going to draw with a line. There's his head. Okay? His shadow is 9 feet long. Excuse me. So do we see how we really could have triangles if we were to connect, right? So let's come up with our proportion. Similar, we have to find the corresponding sides. Well, guess what? The shadows are corresponding sides in my triangles. So I can use 75, I'll change it to black, 75 over 9, right? Flag shadow to man shadow, okay? Or flag to man. We can just use those, F to M. Okay, F to M, because I'm going to carry those labels over, which really, this F talks about the flag height, which is X, the man height, which is 6. I can use cross multiplication. 75 times 6, which should be 450, is equal to 9x. Now I can divide both sides by 9, one-step equation, and x equals 50 feet. So by using indirect measurement, I came up with the fact that my flag is 50 feet high. All right, let's go ahead and take a look where else we can use indirect measurement, okay? A 15-foot tall statue standing next to an adult elephant casts a 15-foot shadow. If the adult elephant is 10 feet tall, how long is its shadow? Okay, so we have a statue, all right? The statue is a person. That's what I'm going to say it is. It's 15 feet tall. And it casts a shadow that's 15 feet. Okay? The adult elephant, right? So elephant, here we go. These are my, okay. I'm not a good drawer. There we go. That's as best I could do. The adult elephant is 10 feet tall, and it casts, we don't know, some sort of shadow. But we can use this idea of proportions. I know that 15 corresponds to 10. Okay? So I have statue to elephant. And I can say My statue shadow length is 15. My elephant shadow length is X. You could probably see that, hey, if this is 15 and this is 15, this X might be 10. But let's cross multiply just to verify. So 10 times 15 is 150 equals 15X. Divide both sides by 15. You bet that elephant shadow length is 10 feet. All right, and the last one. Let's erase this circle. A 6-foot man casts a shadow that is 10 feet long. I'm going to draw him. They're all smiling. A 6-foot man casts a shadow that is 10 feet long. Oops, I'm going to use blue. At the same time, his 4-foot car casts a shadow. How long is the car's shadow? All right, so here's a car. His 4-foot car casts a shadow, okay, 4 feet, casts a shadow that is how long? We don't know. Let's find some corresponding sides. I'm hoping that you'll see 6 corresponds to 4. 6 to 4, so man to car. I'm going to use those same labels on the right-hand side. 10-foot shadow, X. We don't know the car's shadow, but what we can do is we can cross multiply. 4 times 10 is 40 equals 6X. I'll divide by 6, and 40 divided by 6 should get you a decimal. 6.67 feet equals X. So the shadow of the car should be about 6.67 feet long. All right, so that's how we can use similar figures similar figures with proportions in order to use indirect measurement. Thanks for watching.